Hey, welcome to part 2 of today's lecture. This is Friday's lecture. Today, we're going to go into chapter E5 and discuss density. Density is a derived unit. Remember, we were discussing a little bit about our base units. We're going to show that density is derived from 2 or more other units. Now, density is an identifying property of a sample of matter. Matter is anything that occupies space and takes up volume. So a property is a unique characteristic of a sample. So we can use density to identify what a sample is, because all samples of matter have different densities, and that's one identifying feature that we can use to recognize a sample of matter. As we said, density is a derived unit. It's defined as the mass of the object. In the mass, normally it's grams. Sometimes we're going to see kilograms. You might see micrograms. You might see milligrams. Volume, normally it's going to be milliliters for liquids. Liters are typical for gases, and cubic centimeters are really useful for solids. What's really nice about density, we're going to show a little bit later when we start solving problems, density can be used as a conversion factor. If we want to deliver a certain mass of a liquid and we know its density, well, it's easier to prepare a sample of liquid by measuring out its volume. So if we know its density, we know what mass we want, we can figure out what volume is required to give us that mass if we know the density of the sample. So, density. Let's go over a problem. Problems are really important. So let's go over a problem involving how to calculate the density of a sample if we're given some information about it. There's our definition of density. Mass over volume. In our problem, this is an example problem, and there's similar problems in your textbook. And sometimes when we have a problem, it might be a good idea to draw a picture, and I'm going to try to draw a picture in this sample. In this problem, we're given that a metal cube has a side length, one of the side lengths of the cube they give us the side length as 1.14 centimeters. And they also give us the mass of the cube. .67 grams. And the question is, what's its density? Well, remember, density is the mass of the substance over the volume. Metal cube has a side length of 1.14 centimeters, mass of 6.67 grams. Well, if we want to determine the density, we already have the mass. We need to figure out what its volume is. This is going to tell us that, this piece of information, the side of the length of one of its sides. Let's draw a picture. Again, I drew a picture earlier of a perfect cube. We can assume this is a perfect cube. When we have a cube and we know that the length of one of its sides, in this case, is 1.14 centimeters, the volume of a cube is equal to length times length times length, or it's the cube of the length of that one side. So in this case, it equals 1.14 centimeters. And we're going to cube that whole value and the unit. And we're going to put that into our calculator. And once again, like we did in our last video, when we're given information in one step, we're going to retain all that data and not round off. So if we put this into our calculator, the volume of that cube is 1.481544 cubic centimeters. And we're going to use all that data to help us determine what its density is, because this is the volume of the cube. If we put 6.67 in our calculator and divide it by 1.481544, that's going to give us our density. The density of the cube, 4.50 grams per cubic centimeter. Okay, notice my final answer has 3 significant figures because the mass is the piece of data, and the length also. Both the mass and the length only have 3 sig figs. Now, what we're going to learn a little bit about later is how we treat significant figures when we have a lot more data. And what we're going to show is when we start solving problems at the end of Chapter E, probably in our next half of our lecture, next third of our lecture, we're going to show that it's the number with the least number of significant figures when we carry out a series of steps dealing with multiplication and division. It's the number with the least number of sig figs that limit our final answer when we report our data. So that's an example of how we calculate density. We also want to understand a little bit about the very beginning, we were discussing properties of matter. So that's an important issue. I'm going to erase this. Everybody good? As we said, density is an important property of matter. Properties of matter. And this is a topic we're going to discuss more about later in this course. But for now, we're going to introduce ways we classify matter based upon their properties. And we're going to look at 2 classes of properties that help us to better understand a little bit about matter. And we're going to look at 2 types of properties. Intensive properties and extensive properties. Now, what we do is we try to learn more. We try as chemists to learn more about samples of matter because that's what we study. And if we can classify matter based upon its properties, we can learn more about that certain sample of matter. So one way of classifying a property of matter is classifying that property as either being intensive or extensive. Intensive properties, I like to emphasize the in. Intensive properties are independent of the size of the sample. Extensive properties depend upon the size of the sample. Let's go over a simple example. Let's think about volume and temperature. Volume and temperature. Let's look at 2 beakers of water. We have 2 50 milliliter beakers of water. Water, we're going to learn later, is called H2O. And they're both at 25 degrees Celsius. And we have another beaker of water, and it's 50 milliliters. and it's at 25 degrees Celsius. Okay, this is a really good way to just think about intensive versus extensive properties. 50 milliliters tells us the volume, so this is volume. 25 degrees Celsius is temperature. What happens if we combine these two beakers of water? What happens to the volume? If we combine the two beakers of water, we're going to end up with, make it bigger, we're going to end up with 100 milliliters. So what we know, what this little exercise tells us, volumes are additive. And they are extensive properties because they're intensive property. I'm sorry. Volume is an intensive property because it's independent. Start over again.